Okay everyone, so today what we are going to do is cosine rule. So I'm going to teach you how to use a cosine rule to find the length of a side and how to use a cosine to find an angle. But firstly, let's start to do the proof. So the cosine rule. Alright, so I'm just going to write down the formula for you first, alright? And then I'm going to prove to you why the formula is like that. So start with the triangle. Now, we've got two slightly different formula. One is for finding the side, and the other one is for finding the angle. So we'll start with the finding the side, okay? All right, so say for example, this is angle C here, and I've got A and B. So this is angle C, and we know it's B and we know it's A. So we have an idea about A and B, the distance is given, and we know the size of C. And then our job is to find what is the missing side C. So say, for example, C is missing, and I don't know what C equals to. So what is the formula? All right, the formula to find the unknown side can be written as C squared is equal to A squared plus B squared minus 2AB cosine C. All right, so this is the cosine rule formula. Now the question is, why? All right, how is that possible? How is that possible? C squared is equal to A squared plus B squared, which looks very similar to Pythagoras, but however, minus 2AB cosine C. All right, so what I'm going to do is I'm going to show you, all right, this formula. So start with a triangle like this. And let's call this as A, here's C, that's B. So we've got A, B, and C. We've got three sides. All right, what we're going to do is we're going to start to create a right angle triangle again. So let's start to do a perpendicular height. Let's call that H. And then let's call this distance here is equal to X. We're going to use the X for later proof. And then obviously if the total distance AC is equal to B, and then if that distance here is equal to X, then obviously the remaining distance will be B minus X. And of course we can call that point is point D. All right, so we're going to start from the triangle on the right hand side, okay? So the triangle on the right hand side, I'm going to say in triangle ABD, we're going to use Pythagoras. That's a right angle triangle here. So in triangle ABD, the side here, so B minus X squared plus H squared is equal to C squared. Now, try to expand. You get B squared minus 2BX plus X squared plus HX squared is equal to C squared. All right, so you stop at this point. I can't really do anything further than this. All right, what I'm going to do is I'm going to start with another triangle. So in triangle, on the left-hand side, we've got triangle BCD. All right, and I would like you to use the Pythagoras one more time. So you've got X squared plus H squared is equal to A squared. All right, so I hope you have noticed that that's X squared plus H squared. And here's X squared plus H squared. All right, so what does that mean is we can replace this entire X squared plus H squared by A squared. All right, so let's do that. All right, so what we're going to get now is that formula can now be written as B squared minus 2BX plus A squared is equal to C squared. Okay, all right, we're almost there. As you can see, very similar now. All right, we've got C squared is equal to A squared plus B squared, very similar to the formula, minus 2BX. But here it's minus 2AB cosine C. So how do we get to that formula? All right, now we're still going to do the questions in the triangle BCD. All right, I'm going to write it here. So in triangle BCD, cosine C is equal to adjacent over hypotenuse, which is X over A. And then you make X as subject, you get A cosine C. Now, your final step is to replace this X by A cosine C. So therefore, you're going to get a final formula, C squared is equal to, and let's write down A squared plus B squared minus 2BX And we know what's x equals to. So 2ba cosine c. And then obviously you can rearrange between a and b. And that becomes the formula. Alright, so that's how the cosine rule formula comes from. Alright, it comes from the triangle where you divide it into two right angle triangles. And basically you're using Pythagoras. Alright, you're using Pythagoras twice. First one is to the triangle on the right hand side, and then to the triangle on the left hand side. And then there's some algebra manipulations, and you can you should be able to work out the formula by combining another so-called rule here. And you should be able to get the formula. So that's the formula. Now the formula, you don't have to use C, A, and B. You can use any other letters. So it can be written as like a squared is equal to b squared plus c squared minus 2bc, okay, cosine A. It could be different orientations. But what you need to remember is the question will be given as a question where you have an SAS style of triangles. All right, so start with some basic question. All right, let's do a question that's really simple. We're just using the formula straight away. All right, example 1. So we've got a triangle here, and then we've got a side here equal to 10. That's equal to 15, and the angle in between is equal to 40 degrees. Let's do 40 degrees. And obviously the question asks you to work out what's x, right? What's the missing side? Now, how do you know? All right, when you get a question, how do you know if it's using cosine rule or sine rule? Well, firstly, if you're looking at the sine rule, it has to be at opposite sides and opposite angles. Right now, you've got that pair, but you don't have any other pairs, so you can't use the sine rule. Secondly, how do you know if it's using cosine rule? Well, if the angle and the sides are given in the format like SAS, which is very similar to the area format for a triangle, then, well, it's cosine, all right? You can use cosine to do it. So this is a perfect example of SAS. We're going to use SAS to find the side here. All right, so we're going to start using the formula. So we'll write x squared is equal to. I always prefer to write the missing side on the left-hand side. So x squared is equal to. Now the order between a and b doesn't really matter, all right? So you can do 10 squared plus 15 squared. All right, obviously you can do 15 squared plus 10 squared. It doesn't matter. Minus 2 times by 10 times by 15 and cosine c, or cosine the angle here. And remember, this angle must be in between of two sides. So cosine 40 degrees. That's it. All right, that's all. So it's just that simple. As long as you remember the formula, it's really simple. All right, so of course you can do the next calculation by working out all this calculation here using a calculator. So that will be 10 squared, 15 squared minus 2 times by 10 times by 15 times by cosine 40. All right, so you get 95.186 and goes on. Now, just be very careful, all right? This is not the final answer. If you do make some silly mistakes, all right, you get an answer like this. Do check. If you have a 10 and 15, it's not possible to have another side that is equal to 95, all right, that long. It's impossible to create a triangle like this. All right, so remember you need to square root both sides. So x is equal to the square root of that number there, and that becomes 9.76 units, and it's to 2 decimal places. All right, so it's a really simple question using cosine rule here, all right? So when the question is given as SAS, and your job is to find the third side, and this is what you do. Very easy, straightforward, you just apply the formula. All right, okay. Now, there's another cosine rule formula that you need to know. All right, so right now, cosine rule formula is finding the unknown side. But this is slightly different to the sine rule question. All right, for the sine rule formula, you only use one set of formula to find in both unknown sides or unknown angles. You don't need to change the formula. But for the cosine rule, if you want to find the angle, all right, the formula is slightly different to the formula that you find in the side. All right, so I'm going to show you how to find the unknown angle using cosine rule. Another formula. All right, now we have the formula here. C squared is equal to a squared plus b squared. minus 2ab cosine c. That is the formula to find ano side. All right, if we rearrange this formula, all right, slightly, all right, using algebra, we should be able to get another formula to find the angle. All right, say for example, if angle C is missing, and you have all the three sides, how do I find the angle? It's actually really easy. All you need to do is rearrange this formula, making cosine C as a subject. All right, and then rearrange everything. So just write cosine C on the left-hand side so you create another formula. All right, so let's start to do this. All right, so what are we going to do is move everything here to the left and move the c squared to the right. So that gives you 2ab cosine C is equal to a squared plus b squared minus c squared. Now remember, I want to leave cosine C as a subject. So we've got cosine C is equal to a squared plus b squared minus c squared over, you divide everything by 2ab. And that's it. That's the formula. And that is the formula to find the angle. If all three sides are known, all right? So if you know all three sides, then you can use that formula to find the angle. Now, how hard is this formula? It's not hard, right? The problem with that is the order between the sides. As you can see, it's quite important. That's a minus here, so the order is very important. It doesn't matter between A and B, but it does matter between the A, B, and the C. C must be the side that is opposite to this angle. And this is something that you have to be very, very careful. All right, I'd like to show you an example. So that's the formula. Let's start with an example here. All right, I'm just going to write the formula here. So we've got cosine C is equal to a squared plus b squared minus c squared over 2ab. All right, so let's start with an example 2. All right, so remember all three sides have to be given, all right, to find the angles I need. All right, so say for example, this angle here is unknown. I have no idea about this angle, but we know this side is 20, that's 25, and that looks longer than everything else. So let's just make that 32, and hopefully that works, okay? All right, now your job is to find the missing angle here. All right, now the question is, if you have all three sides, all right, the common mistake is students don't know which two sides to use as A and B. What you need to remember is SAS, all right, the side angle side. Side, angle, side. Angle must be between the two sides here. So that means that 20 or 25 could be both, could be A or B. And that 32 would be C, which is opposite to this missing angle here. As you can see from the formula, that's C and that's C. And C is the angle we want to find. And in this case, it's theta. All right, so once we know this, right, then the formula is really easy to actually do the calculation. So it will be cosine theta is equal to, again, doesn't matter between A and B. So I'm just going to write 20 squared plus 25 squared minus C squared, 32 squared, over 2 times by, and according to the formula, it's just A and B, right? 2 times by A times by B. Now, once you finish that, you can use your calculator to work out what's on the right-hand side. So 20 squared plus 25 squared minus 32 squared divided by 2 times by 25 and times by 20. All right, so that's a very nice number here. So that's 1 over 1,000. Pretty good. All right, and then all you can do is that theta is equal to cosine inverse 1 over 1,000, and you should be able to work out what is the angle in between. And the angle I got is 0.9 degree. Okay, that's really interesting. 0.9 degree. Is that correct? Let's double check one more time. All right, nope, I made a mistake. The answer is 89.94 degrees. Excuse me, sorry. All right. I have no idea why I made that mistake. Let's try it one more time. Yep, 89.94. So that angle here is 89.94 degrees after you finish all the calculations here. So just be careful, don't make a mistake. I guess what I did is I didn't do shift cosine. All right, to get to like an inverse cosine of 1/1000, I just did cosine of 1/1000. That's why I get such a small answer here. All right, just make sure that you don't make the same mistake there. All right, that question still looks really easy here. All right, very, very simple. You just, all right, as long as you remember the formula, you should be able to do the question quite easily. All right, we're going to do one more. Let's do an example 3. All right, so this time the question says, find the smallest angle, or calculate the size of the smallest angle. All right, so you've got a triangle like this. Now it's pretty hard to tell which one is the smallest angle right now. And I'm just going to give you the detail of the side. So that's 15. Here is 12. And then that's equal to 10. Okay, that's equal to 10. Now the question can say draw not to scale. So you can't just say, that looks like smaller than the other angles, or this looks like the smallest angle. You can't just make that assumption. How do I know which angle is the smallest? Look at the side. All right, in a triangle, this is very obvious. The smaller the angle, all right, the smaller the side. Obviously, this angle, as you can see, if you have a smaller angle, then the opening is smaller, so the side it creates by this angle is smaller, all right, than the other two sides, all right? It's shorter than the other two sides. So, for example, find the smallest angle here, all right? Obviously, I'm finding this angle here, and let's call that angle x. All right, once you know which angle you're finding, then you should be able to actually work out the smallest angle by using the formula there. All right, so let's try one more time. So cosine x is equal to, which one's A and B? Has to be SAS. That's A and B, and that's C here. So it'll be 12 squared plus 15 squared minus 10 squared over 2 times by 12 times by 15. All right, so cosine x is equal to, do the calculation on the right. And you get 0.7472, and then x is equal to shift. Make sure, remember, you do shift cosine, and that gives you 41.65 degrees, and to the 2 decimal places, and that must be the smallest angle. All right, definitely. You don't need to actually confirm by finding the other 2 angles. That must be the smallest angle because the side that's opposite to this angle is the shortest in the triangle. All right, so that's how you calculate this question here. Still pretty straightforward, as long as you know which angle is the smallest. It's pretty good. All right, now in the next example, I'd like to show you how to do questions, how to find the area of any triangles when the size of the triangle is known. All right, so when the sides of the size of the triangle is all known, and how do we find the area of the triangle? All right, example 4. All right, say for example, I have a triangle like this. Now previously, if you want to find the area of the triangle, you have to use, either half BH or use half AB sine C. But this time, let's just say this time we have a 20 here and an 18 here, and then that is equal to 27. And then the question asks you, find the area of the triangle. Right, with the following detail. How do we find the area of the triangles here? It's not that easy to find the height. All right, so what I will do is I'm going to use the area formula that you have learned before. And that is the formula here. Area is equal to half AB sine C. That is the formula. All right, now, according to that formula, you need angle C, right? You need C. You need one angle. It doesn't matter if it's a C or B or A. It doesn't matter, all right? You just need angle. Right now, you don't have angle. All right, now it doesn't matter which angle you want to find. All right, if you want to find that angle here, yeah, fine, find this angle, and then these two becomes A and B. If you want to find the angle here, yep, this two becomes A and B. It doesn't matter, but what it does matter is you need to find angle. All right, so how about we just find, I'm not going to find this angle here this time, we're just going to find a smaller angle, all right? How about we find this angle here? And that is the smallest angle, by the way, all right? So we're going to find this angle first, all right? Let's call this as x. So cos x is equal to 27 squared plus 20 squared minus 18 squared over 2 times by 20 times by 27. That's cosine x. All right, remember I want to work out what's x, right? So x is equal to, I'm just going to do the calculation to work out what's x. Okay, so it looks like it's 42 degrees. This time I'm just going to write nearest degree for easy calculation. All right, nearest degree, 42 degrees. Once you get 42 degrees, once I know this angle here, then I can start to find the area. So the area is a half AB. Now remember, if I use that angle here, then A and B must be 20 and 27. All right, you can't use 18 anymore. If you want to use this angle as angle C, then that will be the two sides you're going to use to calculate this the area of the triangle. So this time I'm just going to use 27 and 20. And then according to that formula, it will be sine C, 42 degrees. All right, so let's do the calculation. The answer is 179.99, and let's write the nearest answer will be 180 square centimeters. And that's how you find the area of any triangle with all three sides given. So now, after this lesson, you should be able to find area of any triangle if you know all three sides. So you can draw a random triangle, for example, on a piece of paper, and you use your ruler to measure the size of each side, and then you use a trigonometry, cosine rule, and also the area formula. Then done. You got the area of the triangle. Pretty amazing. Okay, all right. Now you are going to get a slightly different question. Compared to the example I showed you. But majority of the questions are all worded questions, and they can combine it with the bearing questions, which I will talk about it in the future lessons. But right now, for the cosine rule, these are the two formulas. One is used to find an angle side, and the other one is used to find an angle angle. Please memorize the formula. It's definitely help you to work with the question. It's much faster to do it. That's all. Yeah. All right. So I'll see you next time.